Hey guys, let's talk about reference versus value type variable. So far, we've seen and used multiple data types. C# has two varieties, value and reference types. All the basic built-in data types are value types, which are also called primitive types. Except for the string, which is a reference type. But it is somehow treated in a different fashion, so we'll see it in more detail at the end. And besides the string, all other classes and arrays are also reference types. The basic difference between reference and value types is how they are stored in memory. Declaring a variable consists of telling the program to reserve a piece of memory to store some data. So we can see a variable as a container that holds a value. A value type variable actually holds the value. Let's see what I mean by this. First, we declare an integer variable called number1 with the initial value of 10. Second, we declare a new integer variable called number2 and we assign it the value of the first one. Right now, both variables have the same value. Now, let's increment the value of the second variable and check their values again. The number1 variable continues with the same value of 10 and the second variable, number2, has the value of 11. So, as expected, nothing happened to the first one. Now, let's see what's happening in terms of memory. We declare the first variable. And then, when declaring the second one, we copy the value from the first variable into the memory space of the second. We can change the value of each variable without affecting the other one. The values of these two variables are completely independent. But now, let's see an example with a reference type variable. We'll use a player class with a score property for this example. Let's perform the same steps as before. We declare a new player object and set the value of the score property. Then we declare another player object and assign it the value of the first one. Let's check the score values of both players. As expected, they are the same. But now let's increment the score value of the second one. And let's check the scores again. Both values were incremented. And this is where reference type variables differ from the value types. Let's see what happens when we declare a reference type variable. When we declare a variable of type player, we tell the program to allocate a space in memory for a reference variable. Then, when we create the player instance, the program allocates a space in memory for the object. When we assign the object to the variable, we are storing just the reference and not the actual object. You see, a reference type variable does not hold the object, but a reference to the object. So when we copy the value to another variable, we are not copying the object, but copying the reference. This means that both variables are referencing the same object in memory. So, when changing the data in one of the variables, we are actually changing the object, affecting all the references. This brings another topic into the discussion, initializing variables. First of all, in C#, local variables must be initialized before they are used. Local variables are the ones declared inside the method's body. And this is true for both value types and reference type variables. Now, with instance variables, it's not exactly required, but we need to be more careful when dealing with value or reference type variables. Instance variables are the ones declared directly in a class. Value type variables, when not initialized, they have a default value. So for example, even if we don't assign any value to an integer or Boolean variable, both of them have an initial value. Now, with reference type variables, it's not exactly the same. Since these are in a way dissociated with the actual object, we need to be extra careful with their initialization. For example, if we try to print the array length without initializing it first, we get a null reference exception. Null is the default value of reference type variables. It's a keyword that represents a null reference. A null reference is a reference that does not refer to any object. So when we try to access a reference type variable that is not referencing any object, we get a null reference exception. So always remember to initialize reference type variables. And let's end this lesson talking about strings. As I said before, a string is a reference type, but it's not treated exactly in the same way as the others. Let's repeat the same example but with strings. We declare a string with the value hello. Then we declare another string and assign it the value of the first one. Both strings have the same value. But now let's concatenate the second string with a new value. The first string kept its original value, while the second one was modified. If strings behaved exactly like the other reference type variables, we would expect both strings to hold the same value. But strings are immutable objects. meaning they cannot be changed after being created. So what appears to be a string manipulation is in fact creating a new string object. In this example, we are not changing the string referenced by the first variable. Instead, we are creating a new one resulting from the concatenation between the original string and the new value. The first string remains unchanged. So, while it's not exactly what's happening under the hood, strings behave more similarly to value type variables when copying values. However, please notice that in terms of initialization, nothing changes. If you try to perform some operation in a string that it is not initialized, you will get a null reference exception.